Testing. Okay. Okay, let's take roll and get started. Is Alan here? Yes, Alan is here. Betancourt,
Here.
Brooks,
Here.
Browning.
Here.
Burnett here. Chansui
Here.
Cook. Darga.
Here.
DeGraw. DeGraw. Oh. Delgado.
Here.
Fitzsimmons. Herringer. Here. Holsworth. Oh, okay, I see it. Jones is here, I think. Yes.
I'm here.
Jordan is here. Cole. Fortune here. Lambo.
Here.
McFadden is here. Naney.
Here.
O'Brien. Ortega. Here. Rodriguez. Here. Smith. Here. Tannen, I saw that name. Tannen.
Here.
And Nanny.
The same
Here.
ones that we had. Just
All right, so before I begin, let me talk about the test. So your first test will be given next week, and basically you guys will be doing your test in any of the testing centers between here, Ocala and Levy. All right. So basically, what's going to happen is that I'm going to send the test to the testing center, and you have to make an appointment. I think they have now where you can go online. I think you have to go to their website and see if you can get a slot for doing the test, and then you take the test on that particular day as scheduled. All right, and I'm quite sure they have some rules that you need to follow. Like for example, you cannot do a test within 1 hour closing time or something to that for the testing center. No calculators, but no phones and I think you need to bring your an ID as well. And what will happen, to answer your question, Mr. Jones, so what will happen is that the test will be available for that week, next week, from Monday through Friday, right? So you have to make an arrangement, as I said before, go on the website and make an appointment as to which date you can do the test that would be convenient for you. All right. So that's basically what's going to happen next week. As far as what the test will be based on, the test will cover chapters 1, 2, and 3. Let me do a quick check of something right here. Right, so 3 is what we'll be covering today, and I need to grade your assignment number 2, which I've not been able to do because of a malfunctioning copy that we have upstairs. But anyway, I'll get that done, and as well as assignment number 3, and I think I'm going to let that be due by Thursday, and then I'll grade all of that and then send it back to you, and then you can have that to review. All right, as well as I'm going to post the answer keys for the assignments as well. If I'm not mistaken, I posted the answer key for assignment 1. Let me check to make sure of that. So you can continue to review that. Oh, no, I didn't. Okay, so let me do that now. Okay, so that's done. All right, so that's basically it as far as the test is concerned. Yeah, so that's it. So today we're going to cover chapter 3. And unfortunately, because of what I mentioned before, the print upstairs is not working. So I was not able to print copies of assignment 3 for today's class, for the class inside here in the classroom. So what I'm going to do now, well, I guess I need to share my screen first. Oh, somebody. Okay, so let me share my screen first. And then I'm going to bring up assignment number 3 for chapter 3. So that we can all work on it together, because again, I'm assuming that you'd have watched the videos concerning this chapter. And just to briefly review a couple of things that was discussed in chapter 3, in the videos for chapter 3. Going to do that. Okay. All right, so here it is. So just to review a couple of things that was discussed in the videos for chapter 3. As I recall, a good portion of it was making a distinction between all forms of matter. Matter, of course, is anything that has mass and volume. And of course, under matter, there are a couple of categories, right, that different substances will fall under. You have basically pure substances and mixtures. And under the category of pure substances, you have elements and compounds, right? Elements are substances which consist of only one type of atom and cannot be broken down into simpler substances, while compounds basically consist of atoms or elements that are chemically combined. They have fixed proportions and can be broken down into simple substances, right? And then you have mixtures, which are basically physical combination of two or more substances. And under mixtures, you have two categories. You have homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures are uniform mixtures. In other words, the composition of the mixture is the same throughout, all right? As far as heterogeneous mixtures are concerned, they are not uniform. So a good example of this would be, for example, cooking oil and water. If you add cooking oil to water and stir it, eventually what will happen, you're going to end up with two separate layers. The top layer would be the cooking oil and the bottom layer would be the water, all right? So that's an example of a heterogeneous mixture, all right? So with that said, let's see if we can answer the questions here in question number 1, right? It says classify the following as a pure substance, and you need to tell whether or not, if it's a pure substance, whether or not it's an element or a compound, or a mixture. And if it's a mixture, you need to say whether or not it's a homogeneous or a heterogeneous mixture. So, what about the answer to A? The air we breathe. Would you consider that to be a homogeneous, well, a pure substance or a mixture? And why? Homogeneous mixture, right? Exactly. Because air is a mixture of gases, right? The main component would be nitrogen. And I think, if I remember correctly, nitrogen is about 80% or just under 80% of the air we breathe, followed by oxygen, which is just under 10%, and then you have some other gases, right? So homogeneous mixture would be the answer. Right? What about a nickel? Nope.
Homogeneous mixture also.
Homogeneous mixture. Nickel, or the nickel that is used to make the coin, is actually a mixture of metals known as an alloy, right? An alloy is basically a mixture of metals, all right? So basically what you do is melt the metal and then you mix it together in the specific proportion that you want, and then let it cool, and that's your alloy, all right? And that's your mixture, homogeneous mixture. All right, C, magnesium. It's a pure substance, so if it's a pure substance, what is it? Is it an element or compound? Element, exactly. So pure substance. Element. All right. And then we get to seawater. Is it a pure substance or is it a mixture?
It is a heterogeneous mixture.
Okay, I would say you're partially right. It is a mixture, but I would say that it's a homogeneous. I'm assuming that we're talking about basically the aqueous part of it, with nothing, like sand or anything like that. So I would say it's a homogeneous mixture, all right? Okay, and the last one in this series, gasoline. Is that a pure substance or is that a mixture? No. Yes, ma'am.
What makes a mixture homogeneous or heterogeneous?
Okay, so a homogeneous mixture is one that's uniform throughout, right? In other words, the concentration of the solution is the same regardless of where the region of that mixture, right? So for example, if you mix ethanol and water, right, you mix it, then the amount of ethanol per water or vice versa will be the same right throughout the mixture. Now, a heterogeneous mixture is one where you can identify the components of the mixture because it's not evenly distributed. So for example, the example I gave before, oil and water, right? When you add oil to water, it doesn't matter how vigorous you stir it, eventually it's going to separate into two layers, right? You're gonna have the top layer, which is the oil, and the bottom layer is the water. So you can identify the different components in a heterogeneous mixture, which you cannot do in the case of a homogeneous mixture.
So is the difference one, the amount of each?
No, it doesn't matter the amount. What's important is that you, in the case of the homogeneous mixture, you cannot identify the different components within that mixture, right? Because they don't separate them, right? So the ethanol and water example, right? No, you cannot look at the mixture and say, okay, ethanol is there and water is down here, or because it's uniformly distributed, right? So that's what a homogeneous mixture is. All right. Okay, so back to the gasoline. So is it a pure substance or is it a mixture? It's a mixture, right? Gasoline is a mixture of a group of compounds known as hydrocarbons, right? Now the question now is it a homogeneous or a heterogeneous mixture? Homogeneous. All right. Okay, so that's basically it for question number one. Now, any questions about any of these? Oh, somebody has a question. Oh, somebody is saying that they, okay, I think, oh, okay, all right. Okay, any questions about any of these? Any questions? Yes, sir.
Did you get a worksheet for this?
No, I did not. I was supposed to print a worksheet out, if I remember correctly, or did you guys get a worksheet?
It was.
That's part of part, chapter two. Oh,
I'm sorry?
It was stapled to chapter 2.
Oh, it was?
Yeah.
That was purely by accident. Okay, so good, you guys got right on it then. Because I was trying to print it, well, I couldn't print it because of the, oh, okay. All right. Not sure how that happened, but it is something I did. Okay, so somebody's asking if we're doing the assignment online, are we supposed to write it? Oh, you're writing it. Oh, right, so you're supposed to answer, Tristan Chansu's question. You're supposed to write it, on a hard copy of the assignment, and then you're supposed to scan it and submit it online, right? If you have the tablet where you can write using your, what do you call it, stylus, whatever. You can read that way as well, as long as it's handwritten, that's the important thing, all right? Okay, any other questions concerning question number 1? Any other questions? All right, so let me, clear this. And then move on now to the next topic, which is basically talking about physical changes and chemical changes. And just to recap what we've discussed in the videos, basically there are 2 types of changes, physical and chemical. In a physical change, there is a change in the substance, but the composition and structure of the substance itself does not change. So an example of this is, for example, converting ice, which is H2O solid, to water, which is H2O liquid, right? Of course, you have to heat the ice to get the water, right? So there's obviously a change in the state, from the solid state to the liquid state. But the composition is still the same, right? It is still H2O before and after the change, right? So that's an example of what we call a physical change. There's a change in the state of the substance, but there's no change in the composition. Now, in the case of a chemical change, which is also called a chemical reaction, basically what happens in such changes is that there's a change in the composition, all right? So for example, using water as an example, if you pass an electric current, and I think this example is actually in the video. If you pass an electric current through the water, you can get the water breaking down to form hydrogen and oxygen, right? So that is an example of a chemical change because you start off with one substance first before anything, which is H2O, and then you end up, after electrolysis, that's what we call that process. After electrolyzing water, you're going to end up with different substances, hydrogen and oxygen. So that's an example of a chemical change. So with that said, let's see if we can collectively answer question number 2. Right? So question number 2 says, label each of the following as either a physical change or a chemical change, all right? And the first of these would be the metal gets warmer. That would be physical, exactly. Explosion of nitroglycerin, chemical. All right. Corrosion of iron metal, chemical. Water condenses on a metal or on the metal. Sorry? Physical. Okay, very good. That's it for this. Now, if you understood what we just discussed here in terms of physical and chemical changes, then the concept of physical and chemical properties will be also clear to you. Now, let me just briefly discuss what we mean by properties. Properties are basically those defining characteristics of a substance. And we can classify properties as either physical or chemical. A physical property is a property that can be observed without the substance undergoing a chemical reaction, right? So things like color, taste, boiling point, melting point, refractive index, and so on, those are all examples of physical properties. Chemical properties are those characteristics that can be observed when the substance is undergoing a chemical reaction, all right? So an example would be the fact that ethanol is combustible, right? Or can be burnt. And the reason why that's a chemical property is because the burning of ethanol is actually a chemical reaction, right? So therefore, the observation that you're making that ethanol is, can be burnt, when exposed to a flame, that is a statement of a chemical property of ethanol. Okay, so with that said, scroll down here a bit. Let's see if we can answer question number 3. It says identify the following characteristics as physical or chemical properties. So the first one is iron forms rust on exposure to air and moisture. So that would be what? Chemical. All right. Density, I'm sorry, zinc has a density of 7.13 grams per mil. Physical. Oops. Silver is a lustrous metal. Physical. Zinc dissolves in dilute hydrochloric acid, producing hydrogen gas. Chemical, exactly. All right, and that's it for question number 3, I think.
If we measured the density of zinc on part B at a different temperature and compared them, would it still be a physical characteristic?
Yes, it still be a physical because again, the composition of zinc will not change. All
Okay,
right,
thank you.
so any property that you can observe where the substance itself does not undergo a reaction, then basically that's a physical property. All right. Okay. Let me clear this. Let's go down. Okay, so here we have a list of different properties, and you are to tell whether or not these properties are either chemical or physical. All right, so let's start with number 1. Here. Okay, so blue color, what would that be? Would be physical, right? So E, density.
Physical.
Okay. Flammability, chemical. Solubility, which means dissolves. Physical. Now, let me just say this. There's some instances where it would be chemical if a reaction is taking place, but we're assuming that it just dissolves and that's it. So like, for example, sugar dissolving in water or, salt dissolving in water, then that would be physical. Reacts with acid. Chemical. Supports combustion. Chemical. Sour taste. Physical. Okay, melting point.
Physical.
Physical, exactly. Reacts with water. Chemical. Hardness. Physical. Boiling point. Physical. Luster. Luster means basically that it's shiny. Physical. Odor.
Physical.
Physical. Reacts with air. Chemical, exactly. Okay, so that's basically it as far as question number 4 is concerned. Any questions about any of these? Any questions? All right. Let me there it is. And let me scroll down. Okay, so now we're going to say whether or not these changes are physical or chemical changes. All right, starting with 1. Sodium chloride dissolves in water. I just talked about that a while ago. That would be physical. Silver tarnishes. Chemical. An apple is cut. Physical. Heat changes water to steam. Physical. Baking soda reacts with or to vinegar. Chemical. Iron rusts. Chemical. Alcohol evaporates. Physical. Ice melts. Physical. Milk sours. Nope. Chemical. Because what's happening is that when milk sours, it's the lactose converted to lactic acid. Right? So that's a chemical reaction. So that's chemical. Sugar dissolves in water. Physical. Wood rots.
Physical.
Nope. That's chemical. It's chemical. Pancakes cook. Chemical. Grass grows. Hmm? Hmm? That is chemical. All right. Tire is inflated. Physical. Food is digested. Chemical. And paper towel absorbs water. Physical. Yes, ma'am.
Why is the frost?
Okay, so basically it's a chemical reaction which basically produces the material for more tissues and therefore it grows as a result of that. That's basically what it comes up with. Of course, it's more complex because you have a series of chemical reactions there, but that's pretty much it. All right. Okay, any other, yes, ma'am.
How we identify the chemical and the physical properties, and you said solubility is.
Yeah.
There's not. When sugar dissolves in water, that's not.
Not a reaction.
But if it dissolved in.
Okay, so if what if
If the sugar was dissolved.
possibly, right? I can't think of an example of sugar causing a chemical reaction while dissolved, but one reaction I can think of, for example, is if you add zinc to hydrochloric acid, right? HCl, right? Now zinc is a solid, hydrochloric acid is in aqueous solution, and you're going to get zinc chloride and hydrogen gas. So basically, what you will observe with your own eyes is the zinc dissolving. But at the same time, the zinc is not only dissolving, it's reacting with the acid to form zinc chloride. So this will be chemical, right? But in most cases where you have a substance dissolved in another substance, it's usually a physical reaction. Or physical change, I should say, right? Unless the substances themselves react with each other to produce new products, then that would be a chemical process. All right. Okay, any other questions concerning number 5? Any other question? Okay, so let me, oops, when did I do that? Let me clear this. Scroll down. Okay, so again, physical and chemical changes you're being tested on in this exercise. So the question says, can you recognize the chemical and physical changes that will happen all around us? If you change the way something looks, but you haven't made a new substance, that's physical, right? Which is what we said before. If the substance has been changed into another substance, a chemical change has occurred. All right, so let's look at each of these, right? And the first one is an ice cube is placed in the sun. Later, there is a puddle of water, and later the puddle is gone. So that would be what? A physical or chemical change? Physical. All right. Okay, number 2. 2 chemicals are mixed together and a gas is produced. Chemical, exactly. A bicycle changes color as it rusts. Chemical. A solid is crushed to a powder. Physical. 2 substances are mixed and light is produced. Chemical. A piece of ice melts and reacts with sodium. Okay, actually the first part is physical, the ice melting, right? And then the reaction with sodium would be chemical. So P first and then C, all right? Okay, mixing salt and water.
It's salt and pepper.
I mean salt and pepper, I'm sorry.
Physical.
Physical. All right, chocolate syrup is dissolved in milk. Physical, all right? Okay, let me clear this and scroll down. A marshmallow is toasted over a campfire. That would be chemical, so C. And then a marshmallow is cut in half. Physical. Okay, very good. All right. So that's basically how that is done. All right, so let me clear this. Scroll down to number 7. Now, in the case of number 7, it says classify each of the following as either elements, compounds, or mixtures. And then it says write the letter X if none of these. All right, so the options are whatever you have here. You're either elements, compounds, or mixtures, or none of these. All right. So let's start off with diamond, which is a form of carbon. That would be what? I'm sorry? An element, exactly. Excuse me. So E, right? Sugar. A compound. Okay, milk. Mixture. Iron. Element. Air, we talked about this already. Mixture. Sulfuric acid. Compound. Gasoline, we talked about this already. Mixture. Electricity. X. It doesn't fall into any one of those, all right? Electricity is basically a form of energy, all right? So it's not, a compound mixture or whatever, all right? Krypton, element. Bismuth, element. Uranium, element. Popcorn, mixture. Water, compound. Alcohol, compound. A pail of garbage, mixture. A dog, mixture again. Ammonia, compound. Salt, compound. Energy. X, exactly. Gold, element. Wood. Element, no. Mixture again. Bronze. Nope. Mixture. Bronze is a mixture of two metals. I don't remember what they are right now, but it's a mixture of two metals. Ink. Mixture. Pizza. Mixture. And then down here, dry ice, which is frozen carbon dioxide. Compound. Baking soda. Compound. Titanium. Element. Concrete. Mixture. All right. Is there any more underneath that? Oh, that's it. Okay, so we have just successfully completed question number 7. All right, any questions about any of these? Any questions? Yes, sir.
How is the dog mixture?
Yeah, it's a mixture of tissue, blood, whatever. Yep. It's certainly not a homogeneous mixture. Right? And it's not a compound because there's no unique composition. So, all right, yes, ma'am.
What, is there like only a few, like a small list of things that are exceptions to that?
Exceptions to what?
Like things that will be like those, is it just?
I can't think of, honestly, I can't think of any. You might be able to identify 1 or 2 substances which doesn't fall, but I can't think of any right now.
Everything that isn't.
Right, everything that's material would fall under elements, compounds, or mixtures, pretty much. Anything that has mass and volume. All right. Okay, let me clear this here. And scroll down. Okay, now this one is interesting. It says you're to match each diagram with its correct description, and the diagrams will be used only once. So therefore, basically, it's a one-to-one mapping between each of these questions here and each of these diagrams. So basically, we have these diagrams. They basically represent atoms of different types in different situations, right? So basically, you have to say which of these boxes containing these atoms, molecules, whatever, would fit the description in each case, right? So for number 1, it says pure element. Only one type of atom is present. So let me turn on my pen here. Okay, so which one of these would fit the description described in number 1? C, exactly. Because you have only one type of atom present in that case. All right. Number 2, mixture of 2 elements. 2 types of uncombined atoms present. E, exactly. All right. Number 3, pure compound. Only one type of compound present. B, exactly. And then number 4, mixture of 2 compounds. 2 types of compounds present. A, all right. And then number 5, mixture of a compound and an element. D. Which you could have arrived at by virtue of that being go to one max vector, but that's it, all right? Okay, any question about this? This one?
Test, are we gonna be allowed to use the packet?
Yes, I'm glad you asked that question. I forgot to mention that. So basically, not only will you get a copy of the test when you go there, you're also going to get a copy of the packet, the same packet which I published in Canvas, right? So for that reason, you need to make sure that you familiarize yourself with it so that when you are doing the test, you know exactly where to look for whatever you want to find.
Is it a physical test? Or
Yeah, physical test, right. Right, so you begin a paper, you need to bring your own pen, of course. I'm not sure if you're gonna need a calculator, but bring your calculator away. And but everything else will be provided for you.
Is the only ones would be allowed?
I'm sorry?
Are these, is this packet the only ones? would be-
Right, you'll be given you'll be given you'll be given this. Oh, there's another page which I'll provide for you, which gives you, I don't think you need it for this particular test, but you're gonna need it later on. But you'll be given this, and there's a another sheet which contains fundamental constants, which I don't anticipate that you need for this upcoming test, but you're gonna need it for the future tests. All right. So you don't need to bring your own copy, that will be provided for you. Okay, any other questions? I think that was the last question in your segment. Yes, that's the last question. Okay. So that's pretty much all I have planned for today. So okay, so any questions concerning this or any other topics? Yes, ma'am.
Will you be posting the old tests for us to look at?
I could do that now, actually.
And our test will be like similar to those questions?
Yeah, I try to, but it depends because from term to term, we may cover different or a different number of topics for each test. So you may, let me see what I can find. Let me go here. Let me go past test keys. Okay, let's see what I can provide for you here. That's a good practice. Okay, let me go here. Publish this one. Okay, so let me do this. Okay, so this is okay, so this is test 1 and test 2 together. I don't remember when this was. Please ignore where it says answer 2 questions. Basically, you'll be given 3 questions, 1 per chapter, and you need to answer all of them, all right? So ignore where it says answer the 2 questions, right?
So there's
What
only 9 questions
I'm
on
sorry?
the test. There's only 9 questions on the test.
No, 3
Oh.
questions. But different parts, like what you see here. So like, for example, number 1, you have an A part where you're asked to do these calculations and round off to the correct number of sig figs. And then number 2 is where we deal with nomenclature. I don't think we covered nomenclature quite yet. Maybe I should not publish this one. Let me get over this one too. But basically, you're going to have different questions. The number 1, 2, and 3 questions, which will be in different parts. Let me see if I can. Okay, let me see here. Test number 1, fall 17. Let's see what this says. Okay. 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 All right, so this is a good representation of what you can expect, right? Again, please ignore where it says answer any questions. So what I'm going to do is publish this one. And let me see here. Let me look at fall 18. Let's see what this says. Okay. 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 All right, so I'm going to publish this one as well. So, so that's fall 18. All right, let me take a quick look at fall 19, test number 1. Again, ignore that part of it. Okay. Yeah, this is a good one too for preparing for that test. All right, so I'm going to publish that one. I think those would be enough sufficient in terms of helping you to prepare, right? For test number 1, right? So you can go there. Let me make sure that this folder is published, by the way. Sometimes I forget to. Okay, so it's published. All right, so go there, you can review that. So basically, in preparation for your test, review these. I'm going to grade your test number 2 and 3 and send it back to you ASAP. Review those. I'm going to post the answer keys for those assignments as well. Review those. And as far as I'm concerned, if you review all of that, you should be in good shape for test number 1. Yes, sir.
There's no class next week.
There will be class next week, right? But it's just that you have to go to the testing center to do the test, right? All right. Any other questions? Any other questions?
We can schedule the test to be 11 a.m.
Yeah, so you have to go online for testing center and schedule the test. All right? Okay, yes, ma'am.
Probably won't happen this week, but I took possibly some of it's happened times, but on certain days, a lot of people schedule their the tests that they take and the slots, there's only so many slots, so.
All right, so, okay, if that happens, let me know. Because I've had that experience before. And basically, the only option I have to do is extend the deadline. That's the only way I can do that. But remember, you can do it not only at here, the citrus, you can do it, you know, if it's convenient for you to do it at the Ocala campus or the Levy campus, you know, that's fine. All right. All right, so if there are no other questions. Oh, somebody has questions online, sorry. Let me see what this person is saying. Right, someone was asking about the keys. Yes, they were from previous years. And another person is asking, is the test only going to be on chapters 1 through 3? The answer is yes. How do I tell them? Oh, and this is based on past experience. I'm glad you said that, Ms. Jones. In order to ensure that you're given the test that you should be given, please specify the course and the test number. I think I need to put something on the test itself so that, because what has happened in the past is that I'll send students there and they will give students tests from a previous semester or previous year. And you know, it kind of messes students up because some of the tests that were given from the previous year, they didn't cover the topic during the current year. So just make sure you specify that the test. What I'm going to do is put the this semester on the test so that there's no mistake as to, you know, that this is the test that you should be getting at that year. All right. Okay. All right. So that's it. So I'll see you guys next week. All right. And of course, if you have any questions, feel free to contact me. Oh, one more thing. I'm sorry. Let me make sure I get everybody who should be here down. Cook. Oh, okay. Davis. Fitzsimmons.
Here.
Okay. Cole. Manny. Okay, that's it. You too. Take care.
Have a good day.
You too. All right, and you guys out there in Zoom. I will be signing off right now.